Hi everybody. There are three forms of a quadratic equation. Standard form, y equals ax squared plus bx plus c is one form. But there are two other common forms. There's factored form, which is a factored equation. So y equals a times x take h times x take k. And if we expand this, we'll end up with x times x, which is x squared being the highest order of the expanded equation. There's another form called turning point form, where it's written in the form y equals a brackets x take p all squared plus q, which again, this x here will expand to being x squared. Now, each of these forms provide us with some information about what the graph looks like. But over here I expanded them so that you expanded an example so you could see how they're still quadratics. Here's the factored form here. I multiplied out the 2, which gave us this. Then I multiplied this out, which gave me this. Then I simplified it, which gave me the general form or the standard form. Let's repeat this back to standard form. Similarly, for the turning point form, if I multiply this bracket out here, I get this expression. If I multiply the 2 through, I'll get this with the 4 added on the end. And if I simplify this, I'll get back to this equation here. So from factored form I can get back to standard form quite easily. It's a bit more difficult to get from standard form to these two forms, and we'll do those in later slides. But let's see what information can be gotten from each of the different forms. So in standard form we can get the line of symmetry by taking this b value here, dividing it by 2 times the a value and taking the negative of it. We can find the turning point by substituting in this value here into this equation, and that'll give us this value over here, which is the y value for the turning point, because the turning point is on the line of symmetry. And we get the y-intercept by substituting in 0 into this equation. So here's an example here. There's our standard form equation. Negative b on 2a, which is this here, negative b 2 times 1. That gives me x equals negative 1. If we substitute negative 1 into this equation, we get the other part of the turning point, which is negative 4. All I've done is put negative 1, evaluated it. There's the turning point. If I want the y-intercept, just substitute in 0 into the equation. 0 plus 0 take 3. It's actually only ever this value here. So y0 is negative 3, giving us the y-intercept of 0, negative 3. And because the value of a, which in this case will be 1, is positive, we know that the equation is concave up. So as an equation, it looks like this. Here's the line of symmetry. Now we know that the turning point, the point on the graph, will be negative 1 comma something. If we substitute the negative 1 into the equation, it gives us negative 4. We find the turning point. If we look at where the graph crosses the x-axis, that's where y is equal to 0. Which is actually quite difficult to do for this equation, so we're not going to do that just now. If we look for the y-intercept, it's where x equals 0. X equals 0 is quite easy. We just substitute x equals 0 into this, and that gave us this negative 3 value, which is there. And then when we're finished, we draw a nice smooth curve through the points that were found. So I suppose the first difficulty is with standard form, it's relatively difficult to get the x-intercepts without using the quadratic formula. So factored form. So if we've got an equation in this form here, we can find these 2 points here by substituting in y equals 0, putting 0 in here. And if we put 0 in here, by null factorial, we know that this has to be 0, that has to be 0, that has to be 0. Well, a is always got to be greater than, has to be not equal to 0, or it wouldn't be a quadratic. In here, to make 0, it's the opposite value of whatever h is, and the same for k. So if y equals 0, it's going to give us these 2 points here. In the case of this equation here, x would be -3 or x would be 1. So that will give us the two x-intercepts. For the line of symmetry, you can see here that the line of symmetry is midway between these 2 points. So if I know what these 2 points are, I can add them together and divide by 2, which is what happens here. It gives me the line of symmetry is x equals -1. To find out the turning point, once I know the line of symmetry, I just substitute -1 back into this equation, which is what I did here, which gives me -4. So I now know the turning point. To find the y-intercepts, just substitute 0 into the equation. So if I substitute 0 into the equation, that'll find this point here, which is what I did there. And a is greater than 0, it would be this value out here. It's 1 in this case, so it would be concave up. And for turning point form, P and Q are the turning point of the equation in the same way that H and K are the x-intercepts. And C over here is the y-intercept. So because it's given me the x value of the turning point here, x is going to be equal to P. The turning point is P and Q. Here's Q over here, remembering to make the negative of P. And the y-intercept will just be substituting 0 for x into that equation. You've got to be a little bit careful with this, because when you substitute in the 0, you're going to get a value from here. So let's have a go. This is probably the easiest one to use. If we're looking for the line of symmetry, it's just the negative of that value there. Well, it's not really. It's solving this equation to equal 0. It's solving this expression to equal 0. Which gives you x equals -1. The turning point, substitute that value into this equation. Oh no, that's not true at all. That's -1. The other part of the turning point is just the -4 on the end. You don't have to change the sign this time. For the y-intercept, substitute in 0. So 0 plus 1 will give me 1. Squared take 4 is -3. The y-intercept's at 0, -3, found from here. And there's the a value in this case is 1. So a is greater than 0, therefore it must be concave up. So that -1 is that there. That -4 is that there. That line of symmetry is that there. And that y-intercept is that point there. Now, what you can see is that all three of these equations, well, this will simplify to that, and this will simplify to that. It's the same graph. It's just written in different ways. And each of the different ways of writing it can find the same information with a little bit more work. The x-intercepts by far are the easiest to find when the equation's in factored form. The turning point's easiest to find when it's in turning point form. The y-intercept's easiest to find when it's in standard form. But you can find all that information from others just by doing a little bit more work. And here's the common information from all three of the graphs summarized here. Now, if you can do this for all three forms, then you're doing really well, and that will help you solve problems with quadratic equations. And it does take a little bit of time to figure out how each of them work and the nuances of each, but once you've done it, it's quite simple. Thank you, everybody.